decision is see. See, while AlexNet is broad, deep convolutional network can be achieved with the good results, but it not offer the general template to guide the subsequent researchers design the new networks. It doesn't have any way forward for this. It doesn't given anything. But AlexNet outperforms the this one LeanNet, right? So there is something called VGG, Visual Geometry Group. The idea of the VGG is the Visual Geometry Group. So what is happening? Group. You keep this word as a group. There are a sequence of the groups. VGG comes into the two flavors, VGG 16 and VGG 19. Two flavors of VGGs. See, the grouping in the sense here we are grouping convolutional, max pooling, and convolutional, two convolutional, one max pooling. We are keeping as a block. This is a one block of architecture. You see here, basically the building blocks of classic neural network sequence of following layers: a convolutional with convolutional layer with convolutional layer, non-linear such as a ray loop being used, pooling layer such as max pooling. Here in this convolutional block, VGG block, convolutional, ray loop, max pooling. See, now you could see the now you see the VGG block, convolutional, one more convolutional, then we have a pooling. See, we are making a architecture into one pools, architecture into groups. Here group 1, here group 2, and these are the final layers. It's a bigger network. It's a bigger network. It's a bigger network. Summarizing key aspects of architecture relevant. Use of very small convolution filter 3 by 3 and 1 by 1. And here the VGG used only 3 by 3 and also 1 by 1. And the low stride, minimum stride of 1. And use of max polling and 2 by 2 and stride with same size. So there is no shrinkage after max polling. The importance of the stacking convolutional layers to get what we are doing, we are keeping this block 1, block 2, block 3 and we are concatenating it. And so the development of very deep we can go with 16 or 19 layers. How many layers we can go? 16 and 19 layers. This is about the VGG net. Anybody have the VGG? Anybody having understood or not understood? About anybody having a doubts on VGG can let me know before we move to the practical. And Meenakshi, I have a question to ask. How can we remove the text text in a image? How can we remove? Meenakshi, this cannot be done with convolution neural network. There is something called we can use OpenCV. So here it's hello. Somebody is unmuted. So, here I'll go on see the VGG net implementation. If you want this code, also I will upload in the GitHub. I'll upload this in the GitHub. You can take it from there. This is the link. You can download it from here. You can see. Now we are going to work on Cipher 10, and which is the here today we are going to work with one VGG block. So basically, with one VGG block is this is called VGG block. Here we have the multiple convolutions followed by pooling, and these are the normal things that you have been converting fully to 1D, and you have the 10 classes out of it. and you have the optimization, stochastic gradient descent, and learning rate and momentum. I will cover this learning rate and stochastic gradient momentum in the tomorrow class. I don't think so. Tomorrow we'll have a class. We'll have a class on Friday. Right? Is it fine? Now, I wanted to have this. I want to prepare and I want to have the model. We wanted to see with one VGG block of the cipher data how it works. What is my accuracy level? Here I am working with and try to understand the epoch's accuracy. Try to understand whether what is happening in this particular area. See, basically, here we are not created. We have only one VGG block. This we call it as a one VGG block, and we have in this convolutional the VGG 16 we have this kind of 15 blocks. We have this sort of blocks. We have 15 blocks in VGG 16. We will write the summary here. We will write a summary here. Now you see my validation accuracy. My training accuracy is increasing 98 to 99. My validation accuracy is around 66. So it meaning of that it is clearly overfit or underfit as what is happening here, overfitting or underfitting. As Shubham overfitting. Okay,
Sir, it's overfitting.
Good. Finally, you learned the concept of overfitting and underfitting. See, my value accuracy is 99, 99, 99. My validation accuracy is my training accuracy. Guys, can you go on mute? I'm getting echo from you guys. Now you see here, I have test accuracy has been to 1. What about my validation? Validation is only 66. Now let it run like 61th epoch. See, there is no improvement in there is no further much improvement in the accuracy. 66 only, 0.66. It's revolving around 0.66. Whereas the training accuracy it is more to 100%. It is able to train properly, but it is failing to generalize. In this scenario, it has been learning, but failing in failing in generalization. There is no much improvement for this. There is no much improvement up to 100 epochs. Now you see my accuracy is 66. When I check here, now you will see my what is happening here. Classification accuracy is good in training, but generalization it is failed. Yes or no, guys? Is it clear? Why I am getting echo voice here?
Yes, sir.
Guys, go on mute, everyone. Or if you join from mobile, just unmute. So let us do something. See, I am getting resource here. Now what I'll do now? Instead of one VGG, I'm using the two VGG blocks. Here, block. Now, if you see here, the block one and block two. What I do here I'll display model dot summary. Right, I'm taking the same data set. I'm running it for again. I have increased the two blocks. Block one and block two. Guys, seriously, it's getting noise here for me, and I could able to hear my voice. Now I have two blocks. Guys, who is joined from mobile? Please log off who is joined from mobile. Because it is giving me the reason. Hello? When it is giving me a reason. Here I have the two blocks where I am running this. Let us see how this will work for us. How does performance will improve? It's not matching with intent. Now you could see this is one block of convolutional. One block. This is again one block. I have the two blocks. Now I am running it for 100 times. Now let us see whether this accuracy will improve or not. If you have any doubt, you can post it, man. So here you could see my accuracy is 71%, but my training accuracy is okay. Now what I will do here, I'm gonna increase the blocks. I'm gonna increase the block one more block. I have a three blocks. So the similar blocks we are stacking into VGG with grouping, visual geometry grouping. Okay. We are grouping the blocks into model and we are performing the operations. So the deep learning we need to have patience and the training process. It's not like it will not happen over period of time, over 1 minute. Okay, this is not a pre-trained. Okay, we need to train the models and we need to understand. The people seems to be they don't have the patience. Now, what is the next one? If this performance is not improving, what is the next options we have? What are the options we can try? Prasad Garu, Prasad, Shweta, everyone. Okay, drop out. What are the other options? Only drop out. Data augmentation, batch normalization. Shweta, why you didn't respond? Shweta, you are not understanding or what? Why the normalization? Batch normalization, by the way. It's not normalization. It's already normalized. When you see this, we already normalized to 0 to 1. Here it's already scaling the pixel happens in the normalization. But we need to use the batch normalization. Now you see it's in like it's bit improving. That's it. It's not going to be like greater improvements. Is there anybody executing from your end? Ash or anybody? Prasad?
Oh, yeah, I'm trying to upload.
Okay. Let it run. So my accuracy got improved from 73. This is 73 accuracy. Here I got accuracy on 71. For one layer increment, there is an increment of only 2%. Let us try to understand, add the dropout to this layer and try to understand whether this will improve or not. I'm adding the first, I'm trying to drop out. So let it run. It is running on at 30th epoch. Wait from your end also, right? That was the main agenda for the sessions. You should do the hands-on, then only you will understand. Otherwise, you will not understand the concept. For while listening, it will be like okay, you are able to get. After the sessions, feel that oh, we missed something else. Okay. See, this one is improving from batch normalization getting improved from 73 to 82. Now let us see other techniques will help us or not. I don't think so. Tomorrow there will be a class, and we'll have a class on Friday. Meanwhile, you complete everything of reading, and tomorrow onwards, day after tomorrow onwards, is a different architectures. It's a different computer vision. See, my accuracy is improved from 73 to 83. What I'll do?